Hello everyone. Myself, Dr. Somshekar MN, Assistant Professor, Department of Chemistry. Today's our concept is symmetry elements. Before going to discuss our concept, let us know about symmetry. What is symmetry? So the term symmetry is derived from a Greek word symmetria, which means measured together. That means an object is symmetric if one part of the object is same as that of the other part. So that then we call it as a symmetry. So you just Google it, you will get this meaning. Okay, symmetry meaning. Let us have a look at certain objects and try to see if we can say something about their symmetric. Now, are at least are they symmetric to us, or do they seem to be symmetric, or we don't find any symmetry in those structures or any objects? So have a look at this picture. It is on a great mahal there in India, that is Taj Mahal, right? uh, so do you find any symmetric? How do you find out is there any symmetric or not? You just do one thing. You just cut this object into two equal pieces. That means two equal offs. You just cut this object in like this, right? So one part of the picture, if is same as that of the other part, one side is same as that of the other side, means then it is symmetric. If one part is different from the other part, means it is not a symmetric. So here, if you cut this object, definitely you will find a symmetric nature. Definitely you will find a symmetric. If you cut one part of the object is same as that of the second part. Now, have you look at a butterfly? Do you find any symmetric nature? Yes, definitely you will find a symmetric nature in this butterfly. So that means again, see, how do you find out whether it is symmetric or not? Is there any symmetry or not? You just cut into a pieces. How many pieces? That depends on you. Okay, that means first you cut into a two pieces. Okay, then try to find out is there any symmetry or not, and again you just cut into like this. Okay, like this. So you're getting now four pieces. Four pieces means one piece, you just take a one piece, that other pieces, there are three other pieces are there, three parts are there, all those three parts are same as that of this first piece or part, then it is symmetric. If it is different, means it is not a symmetric. That means if you cut this butterfly into two equal halves, then only you will find a symmetric nature. If you cut into a four parts, means you don't find any symmetric nature. Same way, you just take a human body, you just cut two pieces like this. Okay, you will find a symmetric nature. Now it is a beetle. So here also you will find a symmetry. If you cut into your two pieces, then you will find a symmetric nature. Yes, it is a symmetry. And coconut leaf, okay, you just take this. Here, if you cut into two equal halves, definitely you will find a symmetry. Same way, here also you will find a symmetric nature. It is a symmetric. So here also, is there any symmetry? Yes. If you cut into a four pieces or two, first you cut into your two pieces, you will find a symmetry. Four pieces, you will find a symmetric nature. That means one part is same as that of the other three parts. So that's why it is a symmetric. Here also, depending on this object, right, you cut into several pieces, you will observe, that means one, two, right, three, four, you can cut into more than four parts. Okay, you will get you will observe a symmetric nature. And this is also world famous tower, that is Burj Khalifa, right? Here you don't find any symmetric nature, because if you cut this Burj Khalifa into two equal halves, right? So here you won't find any symmetry. That means this part, okay, is not appear as same as here, right? And this part, you look, have a look at here, you will not find same side, right? So that's why it is not a symmetric. You won't find any symmetric nature. And try to take a logo. Okay, this is a famous Facebook logo. So here, if you cut this object into two pieces or three pieces or four pieces, you won't find any symmetric nature. That's why it is not a symmetric. And I have taken some other objects like symbols, right? So here I have taken a circle. You can cut into a several pieces. So you will find a symmetry nature. Same way, arrow. Arrow, if you cut into two pieces, then you will find a symmetry. Otherwise, if you cut a four or any more than two pieces, means you won't find any symmetric nature. Here, this is a triangle. If you cut in this way, means you won't find any symmetric nature. Same way, if you this image, if you cut like this, means you won't find any symmetry. A love symbol, if you cut in this way, okay, vertical way, you will find a symmetric nature. Same way, star mark is also a symmetry. There is a symmetry if you cut into two equal halves. Now coming to a chemistry, right? I have taken a trans and cis 2 butene molecule, and here if you cut this molecule into two equal trans 2 butene into two equal halves, either you cut this way or this way. Okay. Now what I will do, I will cut molecule into vertical way. If you cut vertical way, means this part, first part, is not as same that of the other part. So that's why there is no symmetry if you cut the molecule like this. Next, I will try to cut other way, that means horizontal way. So I will cut like this. Now also, so if you cut the molecule like this, horizontal, right? This hydrogen and is not same side as that of the other part, right? Here there is a methyl group is there. Here also hydrogen is here, and this side it is a methyl group. That means it is a different group. That's why there is no symmetry in this molecule. Okay. Now cis 2 between. Let us cut the molecule like horizontal way. Horizontal way. Horizontal way, you won't find any symmetry. If you cut a vertical way, so you will find a symmetry. That means this part is exactly same as that of this second part. So that's why this is between is a symmetric nature compared to a trans 2 butene. So you may get doubt now, sir. Is there any symmetry element in this trans 2 butene? So later on we will discuss for that molecule. Now coming to our concept, that is symmetry elements. So first let us discuss a introduction part. Okay. In introduction, the symmetry properties of molecules can be useful in predicting infrared spectra, describing the types of orbitals used in bonding, predicting optical activity, and interpreting electronic spectra. Now, here we are not going to discuss a group theory, right? Now, in symmetry, so we are going to use some names, that means some words. That is, first one is symmetry element, symmetry operation, point group, character table. So today's concept is symmetry elements. So that's why we will discuss a symmetry element. What is symmetry element? It is a geometric entity such as a line or a plane or a point with respect to which a symmetry operation is performed, that is rotation, reflection, or inversion. Then what is symmetry operation? It is a rearrangement of a body after which it appears unchanged. That is symmetry operation. So that I will explain by taking this simple diagram, pictorial diagram. So first, let us take a symmetry elements. So which are the symmetry elements? Line is symmetry element, a plane is a symmetry element, and a point is a symmetry element. And what are the symmetry operations? Rotation, reflection, inversion. These all are symmetry operations. So along with the line, if you do a rotation, that then we call it as a axis of rotation. So you have a plane, right? Through that plane, if you do a reflection operation, so we call it as a plane of reflection. You have a point, okay? Through that, if you do a inversion operation, then we called it as a center of inversion. Then how many symmetry elements we have? Yes, of course, we have totally 5 symmetry elements. Those are, first one is identity, second one is proper axis of rotation, third one is mirror planes, center of symmetry, last one is improper axis of rotation. Let us discuss first one, that is identity. What is an identity? All molecules have this element. That means you can take any element or any object or anything. Okay, anything. So all molecules have this identity element. So then what is this identity element? So this operation, that means you take a identity element. If you do a operation, so after doing an operation, the entire molecule is unchanged. That means you can take any molecule, you just rotate a 360 degree. Okay, 360. After rotating 360, so what you will get? Suppose I will take my mobile phone, right? What I will do, I will rotate into a 360. Do you find any change in the symmetry? No. So why? Because we are rotating molecule into 360 degree. So that's why you can take not only a mobile, any object. Okay. So there is this element, that is identity element. You can take any object. So rotate 360. So you won't find any change in the symmetry. So that's why we have the identity element in all objects or all molecules. Okay. So in simple way, doing nothing. Okay, don't do anything. Don't do anything. Take a molecule or take a mobile. Don't do anything. So we have a symmetry element, that is a identity element. Next, coming to a second one, that is proper axis of rotation, represented by Cn. So if the rotation of a molecule about an axis through some angles results in a configuration which is indistinguishable. Indistinguishable means you will not differentiate from first one to second one. Okay, indistinguishable from the original, then the molecule is said to possess this proper axis of rotation, denoted by Cn, where C is cyclic, N is number of rotations, 360 by N. Suppose if you will do a 180 degree rotation, means 180 means 360 divided by 180. How much? 2 you will get. N is equal to 2 you will get. Same way, if N is equal to 3 means you are supposed to rotate 120 degrees. If N is 4 means it is 90 degree rotation. That means after doing each rotation, if your molecule is indistinguishable, then there is a proper axis of rotation in that particular molecule. Now let us take a simple example, that is water molecule. We will take on as a simple example. Okay, water. So we know that water is having a oxygen at the center and two hydrogens, right? What is its shape? It is a vertical shape. Okay, vertical shape. Now, so what I will do now, I will take a water molecule. I will rotate that water molecule into 180 degrees. 180 degrees. After rotating this 180, this hydrogen, say it is hydrogen numbering 1, right? Now goes to second position, hydrogen. Okay, just I'm numbering hydrogen 1 and hydrogen 2. Okay, there are two hydrogens are there in water molecule, right? Now if you rotate 180 degree, okay, 180 degrees, okay, after rotating this 180, what will happens? This number one hydrogen will goes here and 2 comes here, right? So after doing this operation, do you find any change in the symmetry of the molecule? Of course, the hydrogens are changed that its position, but the molecule symmetry or geometry, does you will find any change in this change in the geometry? No, you are not finding any change in the geometry. So that's why that configuration after rotating 180, so we will get a one configuration. That configuration we call indistinguishable molecule. It is not as same molecule, identical molecule, but we will get a indistinguishable molecule. This indistinguishable molecule also, you will not find any change in the geometry. So that's why there is a symmetry. Now again, so now I have rotated 180. What I will do? Again, I will rotate a molecule into 180. So now what happening here? So now after rotating second time, the hydrogen 1 comes here, 2 goes to air. Correct? Now look at the first and also last molecule. First one and last one. They are identical molecule, right? So they are identical molecule. Identical molecule, right? Identical. Same. You will not find any change in this even number of hydrogens. Whereas these two are what we called indistinguishable molecule. These are indistinguishable molecules. So that is how we can do a indistinguishable molecule. That is how you have to do a rotation operation. That means water has a twofold axis of rotation. When rotating by 180, the hydrogen atoms trade places, but the molecule will look exactly same. So that's why the water molecule is having what type of symmetry element? What type of symmetry element? C2 we have, right? Cn means C cyclic N. So after rotating 2 times, N is 2 times. So we are getting a identical molecule. That's why what type of Cn element is there? So C2 element is there in this water molecule. Let us take a other example and try to find out what and all symmetry elements are there, what type of Cn axis is there in this molecule. Now I'm taking an example of BF3 molecule. So in BF3 molecule, so we have a threefold axis of rotation. So that means now what I will do, I will number these fluorines 1, 2, 3, right? 1, 2, 3. You just rotate into 120 degrees. So now you will get a doubt, sir, why can't we rotate 180 degree? You just do your operation. You just rotate a 180 degree. Do you find any indistinguishable molecule? If you indistinguishable molecule you will get means definitely there is a C2. If not means there is no C2. Now we are going to C3. C3 means N is equal to 3. That means you are supposed to rotate a molecule into 120, not 180. So that's why I am rotating a 120 degrees, right? Rotate a molecule 120. The F1 comes here, F2 goes here, and F3. That means only fluorine atoms are changed, but not its symmetry or geometry. So that's why this is an indistinguishable molecule. Indistinguishable molecule. It is not a identical molecule. Again, if you rotate 120 second time, so again this F1 comes here, F2 and F3, right? So this after rotating second time 120, 120, now you just compare with first molecule. So both are same? No, it is not a same molecule. So that's why it is a indistinguishable molecule. So one more time, if you rotate 120 and let us find out here, let us find out whether it is a indistinguishable or identical molecule. Yes, of course, I have a boron atom at the center and there are three fluorine atoms over here, right? So now what I will do, I have here this molecule, now I am rotating again 120. So if you rotate a 120, this fluorine comes here, right? Now this fluorine, F2 fluorine comes here, F3 comes here. So you just compare with this molecule and this molecule. Both are same, identical molecule. So that's why we have in this molecule, that means in BF3 molecule, we have C3 element. Okay, rotational element. See what type of axis of rotation is there here? C3. So C3 is there in BF3 molecule. Same way, let us take a other example. So I will take an example of again BF3. Now try to find out, is there any other CN oxys in this molecule? So if a molecule possesses more than one type of N axis, the axis of highest value of N is called as a principal axis. Okay, it is the axis of highest molecular symmetry. For example, in BF3, we have C3. Just now we were discussed, right? C3 is a principal axis. Apart from this C3, we have other axes also. Let us find out which are other axes. Let us have a look at here, right? So now we have a BF3 molecule, fluorine, fluorine, fluorine. And if you take if you pass one axis, okay, one axis or one line along this fluorine and boron, and this axis bisects this fluorine into two equal arcs, right? Two equal arcs. Now you just that means you just cut into your two pieces. What you will get? You will get a two identical pieces. One piece is same as that of the second piece. So that's why there is a C2. Or if you, what you will do, along this axis, you just rotate a molecule into 180 degree. C2 means 180, right? You just rotate a molecule into 180. So you will get a, what you will get? You will get a indistinguishable molecule. Same way, one more axis I will pass along this boron and this fluorine. Again, same result you will get. There is one more C2 you will get. So one more axis I am passing this fluorine, third fluorine, C2, okay, third fluorine and also boron atom. So one more C2. That means we have three C2s are present in this BF3 molecule. Now, which is principal axis? Highest fold, which is highest fold rotational axis here. C3 is highest degree fold, right? Highest fold rotational axis. That is, so that's why C3 is a principal axis. Other C2s are there, right? C2 is lowest fold rotation. Okay, two-fold rotation axis. Okay, so that's why they are called as subsidiary axis. One is principal axis and subsidiary axis. So always there is a relation. That means this principal axis perpendicular to C2 axis. Okay. So now this is these are the some of the rotational axis present in the C3 molecule, and try to find out what and all rotational axis present in all these molecules. That is homework. Next, coming to second one, mirror planes, that we will discuss in the next class. Thank you very much.